Nature is a master architect. It has spent billions of years perfecting its designs. Through evolution, it has solved problems we can barely comprehend. This living laboratory holds the key to unlocking a new era of artificial intelligence. By studying nature, we can create AI that is more efficient, sustainable, and intelligent. For centuries, humans have looked to nature for inspiration. We have modeled our inventions on the wings of birds and the fins of fish. Now we are turning to nature for guidance in the field of artificial intelligence. This is not just about mimicking nature's forms, but about understanding its underlying principles. By deciphering the code of life, we can unlock the secrets of intelligence itself. This journey of discovery promises to transform our world. It is a journey that will redefine our relationship with technology and our place in the universe. Biomimicry is the practice of learning from and emulating nature's designs. It involves observing the intricate details and mechanisms that have evolved over millions of years and applying these insights to solve human challenges. Nature, through its vast diversity, offers a treasure trove of solutions that are both efficient and sustainable. It is about recognizing that nature has already solved many of the problems we face today. From the way plants harness solar energy to the way animals communicate and navigate, nature's innovations are time-tested and optimized for survival. By studying how organisms have adapted to their environments, we can find elegant solutions to engineering challenges. For instance, the cooperative behavior of ants can inspire algorithms for optimizing logistics and supply chains, while the structure of a beaver's dam can inform sustainable water management practices. One of the most striking examples of biomimicry in AI is the development of artificial neural networks. These networks are designed to mimic the way the human brain processes information, allowing machines to learn from experience and improve over time. These networks are modeled after the structure of the human brain. Just as neurons in our brain are interconnected to form complex pathways, artificial neural networks consist of layers of nodes that work together to process data and make decisions. They are composed of interconnected nodes that process and transmit information. This interconnectedness allows for the parallel processing of information, making these networks incredibly powerful for tasks such as image recognition, language translation, and even playing complex games. This architecture allows AI systems to learn from data and make complex decisions. By continuously adjusting the connections between nodes based on the data they receive, these systems can improve their performance and adapt to new challenges. Another example is the design of wind turbine blades inspired by whale fins. The unique shape of a whale's fin, with its bumps and ridges, reduces drag and increases lift, making it an ideal model for efficient turbine blades. These bio-inspired blades are more efficient and quieter than traditional designs. By mimicking the natural design of whale fins, engineers have been able to create turbines that generate more energy while minimizing noise pollution. They demonstrate the power of biomimicry to improve existing technologies. By looking to nature for inspiration, we can develop solutions that are not only innovative but also environmentally friendly. By embracing biomimicry, we can create AI that is not only effective but also harmonious with the natural world. This approach encourages us to think beyond traditional engineering and design principles, fostering a deeper connection with the environment. It is a path towards a future where technology and nature coexist in synergy. By learning from nature's designs, we can build a world that is sustainable, resilient, and in harmony with the planet we call home. The animal kingdom is a testament to the diversity and ingenuity of nature's designs. From the dense forest to the expansive savannas, every corner of the earth is teeming with life, each species uniquely adapted to its environment. This incredible variety showcases the endless possibilities of evolution and the remarkable ways in which life can thrive. The intricate details of nature's creations are nothing short of awe-inspiring. Consider the delicate structure of a bird's wing, designed for optimal flight, or the complex eyes of insects that allow them to see the world in ways we can only imagine. Even the seemingly simple spider web is a marvel of engineering, capable of withstanding forces far greater than its own weight. Animals have evolved an astonishing array of adaptations to survive and thrive in their environments. whether it's the thick fur of polar bears that insulates them against the Arctic cold, or the long necks of giraffes that allow them to reach the highest leaves. Each adaptation is a testament to the power of natural selection. From the intricate navigation systems of birds to the echolocation abilities of bats, nature has equipped these creatures with tools that are both fascinating and highly effective. Birds, for instance, can migrate thousands of miles with pinpoint accuracy, while bats can hunt in complete darkness using sound waves. Each species offers unique insights into intelligence and problem-solving. Dolphins, known for their playful nature, exhibit complex behaviors and social structures that rival those of primates. They use tools, communicate with each other through a series of clicks and whistles, and even display signs of self-awareness. Take, for instance, the remarkable agility and precision of a hummingbird. These tiny birds can hover in place, fly backwards, and change direction with incredible speed. Their wings beat so rapidly that they create a humming sound, a feat of biomechanics that has fascinated scientists for years. Its ability to hover mid-air and change direction with lightning speed has inspired engineers to develop more maneuverable drones. These drones mimic the flight patterns of hummingbirds, allowing them to navigate through tight spaces and perform complex aerial maneuvers with ease. These drones have the potential to revolutionize industries from agriculture to filmmaking. In agriculture, they can monitor crop health, apply pesticides with precision, and even pollinate plants. In filmmaking, they offer new perspectives and dynamic shots that were previously impossible to achieve. The camouflage techniques of chameleons and octopuses are another source of inspiration. Chameleons can change their skin color to blend into their surroundings, a skill that helps them avoid predators and communicate with other chameleons. Octopuses, on the other hand, can alter both their color and texture, making them masters of disguise in the underwater world. By understanding the mechanisms behind their color-changing abilities, scientists are developing new materials for adaptive camouflage and dynamic displays. These innovations could lead to advancements in military technology, fashion, and even architecture, where buildings could change color to improve energy efficiency. The animal kingdom provides a rich tapestry of examples for AI researchers. By observing how animals interact with their environment, solve problems, and communicate, we can gain valuable insights into creating more sophisticated and adaptable artificial intelligence systems. By studying animal behavior and physiology, we can unlock new possibilities for artificial intelligence. Researchers are already using principles derived from animal behavior to develop robots that can navigate complex terrains, interact with humans in more natural ways, and even learn from their experiences. We can create machines that are more adaptable, responsive, and integrated into the natural world. As we continue to learn from the masters of adaptation and intelligence in the animal kingdom, the potential for innovation is boundless, paving the way for a future where technology and nature coexist harmoniously. Nature is replete with examples of collective intelligence, where groups of individuals work together to achieve a common goal. This phenomenon is not just fascinating to observe, but also offers profound insights into how simple creatures can achieve complex tasks through cooperation and coordination. Flocks of birds, schools of fish, and colonies of ants all exhibit this remarkable phenomenon. Each member of these groups follows simple rules, yet the collective behavior that emerges is highly organized and efficient. These groups demonstrate that complex behaviors can emerge from simple rules followed by individual members. For instance, ants use pheromone trails to communicate and coordinate their activities, ensuring that food is efficiently gathered and brought back to the colony. The mesmerizing dance of a starling flock, known as a murmuration, is a prime example. Each starling follows basic rules of alignment, separation, and cohesion, resulting in breathtaking aerial displays that protect the flock from predators and help them navigate. Thousands of birds move in unison, creating intricate patterns in the sky. This synchronized movement is not directed by a single leader, but is a result of each bird responding to its immediate neighbors. This coordinated movement is achieved through local interactions between individual birds, each responding to the movements of its neighbors. This decentralized approach ensures that the group can quickly adapt to changes and threats in their environment. This principle of swarm intelligence has inspired the development of algorithms for optimizing complex tasks. By studying how these natural systems operate, scientists and engineers have created algorithms that can solve problems in ways that are efficient, scalable, and robust. These algorithms are used in a variety of applications, from routing traffic to controlling swarms of robots. For example, traffic flow optimization algorithms can reduce congestion and improve travel times by mimicking the way ants find the shortest path to food sources. By mimicking the collective intelligence of nature, we can create AI systems that are more robust, adaptable, and capable of solving complex problems. These systems can learn from their environment and make decisions that benefit the group as a whole, much like a flock of birds or a colony of ants. The study of collective intelligence in nature offers a glimpse into the power of decentralized systems. These systems do not rely on a central authority, but instead operate through the interactions of individual members, making them highly resilient and adaptable. It highlights the potential of AI to not only mimic individual intelligence, but also to harness the collective wisdom of groups. By understanding and applying the principles of collective intelligence, we can develop technologies that are more efficient, resilient, and capable of tackling the complex challenges of our world.